In this video, we will work on two problems of BmMT, Berkeley Mini Math Tournament, and we will work on 7 ideas, background ideas, and I leave 7 related homeworks from Promise Summer Camp, Prestigious Summer Camp, AMC, and also other exams to improve your problem solving in the ideas. If there are around 40-50 important ideas in each topic, these ideas. If you want to learn those 40-50 important ideas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description comments here. I will tell you when we have n through, you should use what two approaches. Here we should use both of them. Vieta special case of Vieta's formula as idea number 2, number of positive divisors, sum of positive divisors, product of positive divisors. And for these things, you should use rainbow for idea 5. You should use rainbow idea or ghost idea. Some problems of IMO also can be solved with this idea. Idea 6, pi principle of inclusion and exclusion for case 3 when we have 3 subsets. Idea 7 when we have K subset general form of pi. And okay, let's try the problems. BmMT 2023 team round. Let's solve, for example, between these problems. Problem 15. This is compute the product of all real solutions x to the equation x squared plus 20x minus 23 equals 2 times square root of x squared plus 20x plus 1. Okay. In my previous videos, I said that when we have a square root, we have two approaches. One of them is to raise to the power of 2, or also let me tell you in general, nth root, raise to the power of n. Second one is to use changing variable, okay? Changing variable. For example, sometimes it's good to consider this one as a variable or something similar to that. Okay, so now try this problem first on your own by the approaches that I've told you here. Okay, here let's try. Sometimes we can use both of them. This part and this part are so much related to each other. They are what? Here we can say, okay, for example, this part is A. This part is A plus what? 24. Now we can say we use changing variable. A equals 2 times root of A plus 24. Then here we use first approach. Raised to the power of 2. So A squared equals 4 times A plus 24. So if you take all things to the left hand side, A squared minus 4A minus 96 equal to 0. Now, for solving this part, we can use quadratic formula or we can check factorizing first. 96 is 8 times 12. So we can write as A minus 12, A plus 8 equal to 0. So the first part is 0, A is 12 or A is negative 8. A is what? X squared plus 20x minus 23. For this one, x squared plus 20x minus 23. So here we can say x squared plus 20x minus, let me tell you something. A plus 24 should be at least 0. In both cases, it is at least 0. And here, we should only check product of all real solutions. So 20x minus 33 and, okay, 35. We can calculate the roots, or we can only check that are the solutions real or not to calculate discriminant or delta. B squared 20 squared minus 4 times this, it's 4 times 35. It is positive, so the roots are, I can say, real. X squared plus 2x minus 23 plus 8 minus 15 equal to 0. Again, here, discriminant is positive, and here the product is negative. Let me tell you something. Idea 2, here it was idea 1. Idea 2, Vieta's formula here. When we have ax squared plus bx plus c, product of roots r1, r2 equals c over a. And sum of the roots equal to negative b over a. If you want to know the roots separately, it is negative b plus minus square root of b squared minus 4ac all over 2a. Okay, so if you check first one, suppose first roots here r1, r2 equal to negative 20 plus minus 400. Here it's 140, 540 over 2a. And here suppose roots are r3, r4 is negative 20 plus minus square root of 400, 460 over 2. Okay, so as you can see, if we simplify, for r1, r2 are negative 10 plus minus square root of, if you divide by 4, it will be 1. Inside square root, we should divide by 4. 114, 325, 135. And 135, we can say it's 5 times 27. Okay, so it's negative 10 plus minus 3 root 1 by 5. And R3, R4 equals negative 10 plus minus, we should divide it by 4. It will be 150. And it will be what? 5 times 23. Okay, now we will see our roots are different. So R1, R2, R3, R4 by this formula. C over A, negative 35 times negative 15. So it will be what? It will be 5 times or 3 times 35 is 105 times 5, which will be 525. Let me tell you something here. Here we've reached that a equals 2 times a plus 24. Because a equals this, a should be at least 0. Okay, so we can reject a negative 8. Okay, so if we check this part, we should check only R1, R2, which is negative 35. Okay, so the answer is this. Let's try another problem. Okay, now let's try problem 16. Compute the number of divisors of 729 million that are perfect powers. A perfect power is an integer that can be written in the form a to the b, where a and b are positive integers and b greater than 1. Okay. For previous problem, let me tell you two homeworks. One homework is for SMC Senior Mathematical Olympiad UKMT for UK 2022. Okay, you can solve that problem. It had a square root. Okay, when I released the solutions of SMC UKMT 2022, I exactly explained. And homework 2 is another problem that I told in that video. Okay, if you want, I should search. If you want to know exactly those problems or what, feel free to send message to my WhatsApp number in the description and comments. Okay, for next problem, at first let me tell you number of, for example, idea 3, number of positive divisors. How we can calculate. For example, for 2000, 2400 is 2 to the 5 times 3 times 5 squared. So when you want to consider a divisor, it has 0 to 2 to the 1, 2 to the 2, or 2 to the 5, 6 cases. Times for 3, 3 to the 0, 3 to the 1, 2 cases. For 5, 5 to the 0, 5 to the 1, 5 to 2, 3 cases. So it will be 36. We should add the powers by 1 and then multiply them together. It is idea 3. Now we know this base idea. Also, idea 4 is sum of positive divisors you should know. And then product of idea 5. Product of positive divisors. This problem probably we don't need, but they are important, you should learn. And homework 3, one problem of Promise 2022, prestigious summer camp at Boston University in USA. And homework 4 is you have AMC problem related to number of positive divisors and also related to sum. 2 AMC problem. I should search them. If you want to know those problems or want to learn more ideas, feel free to send message to my WhatsApp number in the description and comments. Now for solving this problem, first we should prime factorize 729 million. Each 0 is 1 to 1, 5, so it's 2 to the 6, and 7 to 9 is what? 3 to the 6 times 5 to the 6, okay? Now that you've learned idea 3, try this problem first on your own. Okay, so let's check cases that B is 2 first, okay? So for 2, you can select 2 to the 0 or 1 or 2, 0, 2 squared, 2 to the 4th, 2 to the 6th. 2, 4 cases. For 3 also 4, for power of 5, 4 cubed. It is for B2. For B3, you can select 2 to the 0, 2 to the 3, 2 to the 6. 3 times 3 times 3. 3 cubed. We don't need to check B4 because here we've calculated. When I say B2, I mean that all powers should be even, okay? Then, for example, look, if we select 2 to the 4, it is like 2 squared, okay? The power can be 2. Now here we've calculated all numbers. That B is 2, B3, B4 is a special case of 2. In B2 we've calculated before. B5, 2 to the 0, 2 to the 5. 2 to the 0 and 2 to the 5. 2 cases, 2 cases, 2 cases. 2 cube, we don't need to calculate B6 because we've calculated that B2, B3. Let's consider this one as B2, this one B3, this one B5. So the answer is what? The answer is, let's define it as subset, for example, or I think B2 is okay. The answer is B2, 4 cube plus 3 cube plus 2 cube, but we should use pi. Idea, it will be what idea? Idea 6. Principle of inclusion and exclusion. If you want to calculate A union B union C, it will be A plus B plus C minus A intersect B minus A intersect C minus B intersect C plus A intersect B intersect C. You can easily prove it by Venn diagram, or also without that you can prove it. So prove it as homework 6. And also let me tell you, idea 7 is the formula for A1 union to AK. Okay, is what? This absolute value for subset means number of elements. A1 to AK, then minus A1 intersect A2, all pairs A1 intersect A2 intersect A3. And the last one is A1 intersect to AK. And the sign is what? -1 to the K plus. As homework 7, try to prove this. Okay. Now let's work on the answer. Is 4 cubed plus 2 cubed plus 3 cubed minus intersections. Intersection of these parts. Let's consider B2, B3. Okay, B2 intersect B3. B2, B3 are numbers. I mean that the cases that here we have in common. So the powers are multiple of 2 and multiple of 3. So it will be multiple of 6. So 2 to the 0, 2 to the 6 are in common. 2 to the 2 cubed minus B2 intersect B5. Multiple of 2, multiple of 5. So it will be 1 cubed because only 1. For both of them, 2 to the 0 is in common for both of them. B3, B5, again -1, B2. Or we can say 1 cube, B2 intersect B3 intersect B5. Again, 1 cube plus 1 cube. So it will be what? It will be 64 plus 27 plus 8 minus 8 minus 1 minus 1 plus. You can cancel these things. 64, 27 minus 1, 26. So it will be what? 90. Okay. So the answer is this. Now we worked on how many ideas? 7 ideas and 7 homeworks. Okay. 7 ideas, 7 homeworks. If you want to learn more ideas or want to work on more homeworks, related homeworks, want to prepare for This exam or another exam, feel free to send message to my WhatsApp number in the description and comments. As I said before, there are around 40-50 important formulas and ideas in each topic: combinatorics, algebra, number theory, and geometry. If you want to learn them, you can send message to my WhatsApp number. Okay, thanks for watching this video. Bye.